In question 5, we have the same table of trees from before, and now we're going to be looking at some visualizations related to it. So part A has a scatter plot with wood density and height. So which of the following are valid conclusions that we can draw? Choose all that apply. So there can be multiple right answers. So there is a positive association. I would say yes. You can see values tend to go higher as the wood density goes higher. So we'll say yes here. There is a negative association. I don't think so. There isn't. Then there is no association. No, there is a positive association, so it's not that. Then it says there are more short trees than tall trees, and they define it by 60 meters tall. So if we draw a line here at 60 meters, we can see that, yeah, there are quite a few short trees, but very few tall trees. So yes. Okay. Then in this forest, higher wood density causes trees to grow taller, and the key word here is causes. You can never conclude causation from a scatter plot. We can only do that by doing a randomized controlled experiment. But purely looking at the trends from a graph or a scatter plot can never conclude causation. So these next 4 options are all no because of that word causes. And that's a huge pitfall that many people fall into sometimes. Correlation is not causation, and a graph can never show causation. Okay. Then the last one says that the burnt trees are shorter than unburnt trees. Who knows if that's true, but this graph says nothing about that. It only looks at height and density. So we're not going to check that box. Okay. Then it says, suppose you want to visualize how common different types of trees are in the forest. So which line of code generates the best visualization? So first we have to think about like what type of graph we want to do. So we're comparing 2 variables, the type of tree and the number of trees there are, because how common indicates like how many are there. So we have one numerical variable and one categorical variable. And the best way to visualize that is with a bar graph. All right, so we can do like something like a bar for oak, a bar for redwood, etc. So how do we do that? We first need to get all our trees. We first need to count how many of each tree there are. And the way we do that is by grouping by type. So that instantly eliminates the first 3 options. So then the only difference now is the type of graph, histogram, bar graph, or scatter plot. And we already said we want to do a bar graph. So this is our answer. Okay. Now we have the wood density of burnt trees. So this is burnt. And then the wood density for unburnt trees. And basically we're seeing here, like, is there any association between the type of tree or the burntness of a tree and the density of a tree? So we have a bunch of conclusions here, and we have to determine are they valid or not. So part C is more than half of the burnt trees have a density above 0.5. So let's draw a line here at 0.5. So to the right is all the greater than 0.5. So if we look at this, we can see that, yeah, more than half definitely do have a density above 0.5. Okay, part D is getting burnt causes a tree's wood density to increase. Again, the key word here is causes. This is not valid. And our reason why is that you can't prove causation from a graph. Okay, Part E is among trees whose wood density is between 0.8 and 0.85, the number of burnt and unburnt trees is about the same. So let's go back and look at the graphs. So 0.8 to 0.85 is this bar right here, and the height is about 350%, and the bar here is also about 358%. Despite the fact that the height of the bars is about the same, this is not a valid conclusion because we know that the percent of trees is the same. However, we don't know how many are burnt versus not burnt. Sorry about the spelling. For example, there could be like 500 unburnt trees and 5,000 burnt trees. And so the same percentage of one is they're not going to be the same number. So this is not a valid conclusion. Okay, part F. About 25% of the burnt trees have a density between 0.75 and 0.8. So we go to the burnt trees. We look at this bar right here. And the height is 400% per unit. And so to get the area, we need to multiply the base times the height. So the base is, it's going to be 0.05 because this gap of 0.2 is split into 4. So that's 0.05 times 400%. And that's equal to 20%. So 20% of the burnt trees are in that range. And this says about 25, so it's not valid. And our reason is that 20% is not about 25%. Okay, part G, about 300 unburnt trees have density between 0.6 and 0.65. This is invalid for the same reason that part E is invalid. It's that we know what percent of the unburnt trees are in that range, but we don't know how many unburnt trees there are in total. So we cannot say an exact number unless we know the total amount of trees.